Hi students, today our topic is some problems on quadratic form and how to finding the rank, index, signature and nature of the given quadratic form. So how to in the previous lecture we are discussing the some example on quadratic form and definition of rank, index, signature and value class, that is nature. Okay, now we do the problems on quadratic form. Okay, now see the first example. Determine the nature, rank, index and signature of the following quadratic form, that is x square plus y square plus z square plus 2xy plus 6xz plus 2yz. Okay, that is the given quadratic form. That is equal to, let given quadratic form q is equal to x square plus 5y square plus z square plus 2xy plus 6xz plus 2yz. Okay, so first of all write matrix form, that is q is equal to x transpose ax, that is finding the coefficient matrix. So q is equal to x transpose ax. So x transpose is unknown, is three unknowns x y z, that is this is x transpose. So this is a matrix A kada, and x square coefficient to y square coefficient to z square coefficient or diagonal element, that is 1 5 1. Next to xy coefficient to 2 kada, and 1 1. So this is 1, this is 1. Okay, so next one xz coefficient 6 half, that is 3 3, this element. Next to last 2yz, so 2yz coefficient 2, that is 1 1. So this is 1, this is the 1, this is the matrix form. Okay, na? So where coefficient matrix A is equal to that one. Okay, so how to finding all definitions here, rank, index, signature and nature. We have to choosing eigenvalues. They both are two ways, depend on the eigenvalues and depend on the canonical form, but here not convert canonical form by using the eigenvalues of the coefficient matrix. Though finding the eigenvalues here, I can already finding eigenvalues, same procedure by using the quadratic characteristic equation here, finding the lambda value, delta of A minus lambda is equal to 0, that is characteristic equation, finding lambda values, that is equal to here delta of A minus lambda is equal to 0, that is equal to only 1 minus lambda 1 3 1 5 minus lambda 1 3 1 1 minus lambda is equal to 0. So solving this equation we have to finding lambda values, and already we discuss chesamo, directly I am telling here lambda values. So lambda is equal to minus 2 comma 3 comma 6, this is the eigenvalues only. So we can do, that is solving the equation. Okay, now using the eigenvalues you have to finding rank, index, signature and nature. Okay, so that is equal to, here what are the eigenvalues are minus 2 3 6 అంటే positive as well as negative. అప్పుడు నేచర్ ఏమవుతుంది, that is nature is of quadratic form is yes indefinite. మనకి eigenvalues positive and negative both exist, then the nature of the given quadratic form is indefinite, that is equal to, since they are positive as well as negative eigenvalues, then the nature of given quadratic form is indefinite. Okay, na? Next to rank means the number of non-zero terms. So how many number of non-zero terms? Only 2. Rank is, sorry, number of non-zero eigenvalues. So number of non-zero eigenvalues 3 kada. So minus 2 3 6, total non-zero eigenvalues are 3. So rank is equal to 3. Next index is the number of non-zero positive terms. So number of non-zero positive terms here 3 6, only 2 numbers. Therefore index is 2. So index is number of positive eigenvalues is 2. It is index. Next signature, the difference between positive and negative values. So number of positive values, eigenvalues 2. Number of negative eigenvalues 1. The 2 minus 1 is equal to 1. So that is equal to signature is 1. This is defined on the eigenvalues of characteristic equation of coefficient matrix of quadratic form. Okay, now this is a procedure to finding nature, rank, index and signature. Okay. Yeah, next example. So same procedure, determine the nature, rank, index and signature of the following quadratic form: 6x square plus 3y square plus 3z square minus 4xy minus 2yz plus 4zx. Okay, so that is equal to same procedure. Let assumption q is equal to given quadratic form, so converted to matrix form, that is equal to x transpose ax. X transpose is number of unknowns 3, that is the matrix xyz. Okay, now so coefficient matrix, so x square coefficient, y square coefficient, z square coefficient are diagonal elements, that is 6, 3, 3. Next to xy coefficient to minus 4 kada, half, this is minus 2, minus 2. Next to y zx coefficient, next to xy tarvata zx or xz coefficient plus 2 4 ante 2 2. Next coefficient yz coefficient minus 2 kada, ante minus 1 minus 1. Okay, this is a matrix notation, that is coefficient matrix is A is equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, next one, now finding eigenvalues. So eigenvalues of the given matrix A, that is the characteristic equation is delta of A minus lambda is equal to 0. So that is equal to delta of 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda. So now finding determinant of this one and equating the equation 0. Now finding the eigenvalue lambda, I am telling the directly eigenvalues here. Eigenvalues lambda is equal to 8 2 2. So all eigenvalues are non-zero positive. So now we define first of all nature. So nature is all are positive with eigenvalues. So therefore given quadratic form is positive definite. So all are positive. The nature of given quadratic form is positive definite. Yes. So next rank of the matrix. Rank is the number of non-zero eigenvalues. So number of non-zero eigenvalues 3. So rank is 3. So next index. Index is the number of non-zero positive terms, non-zero positive eigenvalues. So non-zero positive eigenvalues 3. So index is also 3. Next signature. Signature is the difference between positive and negative eigenvalues. That is equal to positive eigenvalues 3, negative eigenvalues 0 kada. That is equal 3 minus 0 is equal 3. So this is a signature. Nature, rank, index, signature. So this is a second example. Okay, see the next one. So determine the nature, rank, index and signature of the following quadratic form: x1 square plus 4x2 square plus x3 square minus 4x1 x2 plus 2x1 x3 minus 4x2 x3. Okay, na? Same procedure. Let q is equal given quadratic form. So write the matrix notation x transpose ax. So x means the matrix of 3 unknowns x1 x2 x3, that is equal to x1 x2 x3. So matrix A coefficient matrix. So first variable coefficient x1 square coefficient 1 4 1, and that is the diagonal elements 1 4 1. Next x1 x2 coefficient, x1 x2 coefficient minus 4 kada, that is equal to minus 4 to minus 2. Next x1 x3 coefficient 2 ante 1 here 1. Okay, next to x2 x3 coefficient to minus 4, that is minus 2 minus 2. So this is the next to x, this is the column matrix x. So that is equal to coefficient matrix is A is equal to 1 minus 2 1 minus 2 4 minus 2 1 minus 2 1. Okay na? So same procedure now finding the eigenvalues of the given coefficient matrix. The characteristic equation is delta of A minus lambda is equal to 0. So that is equal to delta of 1 minus lambda minus 2 1 minus 2 4 minus lambda minus 2 1 minus 2 1 minus lambda. So simplification, that is the solving this equation we getting the lambda value, that is eigenvalues. I am telling directly here. So here eigenvalues lambda is equal to 0 comma 0 comma 6. Okay na? So now finding the nature, rank, index and signature. Okay, so nature is eigenvalues are positive and 0 kada, ante positive exist and 0 exist. So nature is positive semi definite. Like 0 exist అయింది కాబట్టి semi definite, that is positive semi definite. Okay na? So this is positive semi definite nature. So next to rank, rank is non-zero eigenvalues. Non-zero eigenvalues is only 1. 6 is only 1 kada, so rank is 1. So next one index, index is the number of non-zero positive eigenvalues. Number of non-zero positive eigenvalues only 1, that is also index is 1. Okay, next signature, the difference between positive and negative eigenvalues. So positive eigenvalues is 1, negative 0, and 1 minus 1, that is equal to 1. This is a signature. Okay, so next example. So okay, determine the nature, rank, index and signature of the following quadratic form: minus 3x square minus 3y square minus 2z square minus 2xy minus 2z plus 2yz. Okay, that is equal to here same procedure, q is equal to minus 3x square minus 3y square minus 3z square minus 2xy minus 2xz plus 2yz. Same matrix notation, x transpose ax. So number of unknowns 3, that is equal to xyz, x transpose. This is a coefficient matrix. So x square coefficient, y square coefficient, z square coefficient are diagonal elements, that is minus 3 minus 3 minus 3. Next to xy coefficient minus 2 and half of, this is minus 1 minus 1. Next to xz coefficient minus 2, that is half minus 1 minus 1. Next to yz coefficient 2, that is 1 1. So this is the x. So therefore coefficient matrix A is equal to minus 3 minus 1 minus 1 minus 1 minus 3 1 minus 1 1 minus 3. So this is a coefficient matrix. Now finding the eigenvalues. First choosing characteristic equation, that is delta of A minus lambda is equal to 0. So delta of minus 3 minus lambda minus 1 minus 1 minus 1 minus 3 minus lambda 1 minus 1 1 minus 3 minus lambda is equal to 0. Solving this equation we are getting the eigenvalues lambda value. So lambda is equal to, I am telling directly here, so lambda is equal to minus 1 minus 4 minus 4. Okay, now this is a negative eigenvalues. Okay, now define the nature. So nature is all eigenvalues are negative. So that is equal to negative definite. All are negative out in negative definite nature. So that is equal to nature is negative definite. So next one, rank. Rank is number of non-zero eigenvalues. Non-zero eigenvalues is 3. 3 non-zero eigenvalues, -1, -4, -4. All are 3 non-zeros. That is equal, rank is 3. So rank is 3. Next one, index. Index is the number of non-zero positive eigenvalues. There is no positive eigenvalues here. So index is 0. So that is equal, index 0 and there is no positive eigenvalues. So next is signature. Signature is the difference between positive and negative eigenvalues. Positive eigenvalues 0 minus negative eigenvalues 3, and 0 minus 3 is equal to -3. So this is a signature. Okay. Yeah. See the next example. Find the value of k so that the value class of the quadratic form k into x square plus y square plus z square plus 2xy minus 2yz plus 2zx is positive definite. And already given in the question, the given quadratic form is must to be positive definite. Then what is the k value? When the k value is substituting, that is a positive definite, that is finding k value. The positive definite means the eigenvalues of the coefficient matrix of the quadratic form is must to be non-zero positive. అన్నీ కూడా non-zero positive అయి ఉండాలి. Then that quadratic form is positive definite, that is finding the k value here. The same procedure. So given quadratic form k is q is equal to, so the matrix notation x transpose ax is equal to, here x square y square z square coefficient k అంటే diagonal elements only k k k. So that is equal to x transpose is number of unknowns 3 x y z. So this is matrix coefficient a k k k. Next xy coefficient 2 కదా, అంటే half 1 1. Next zx coefficient 2, that is 1 1. yz coefficient -2, that is -1 -1. So therefore a is equal to here, so a is equal to this coefficient matrix k 1 1 1 k -1 1 -1 k. So now finding eigenvalues of this matrix. Okay na. So that is equal to characteristic equation, data of a minus lambda is equal to 0, that is equal to data of k minus lambda 1 1 1 k minus lambda -1 1 -1 k minus lambda. Now solving this equation, we getting the lambda value, that is the eigenvalues. So directly I am giving here lambda values, eigenvalues. Lambda is equal to k plus 1 k plus 1 k minus 2. This is the 3 eigenvalues only. But so given quadratic form is positive definite కదా, అంటే k plus 1 k plus 1 k minus 2 must be ఎలా ఉండాలి, greater than 0 అయి ఉండాలి అవునా. ఆల్ ఆర్ గ్రేటర్ దాన్ 0 అంటే నాన్ జీరో కంపల్సరీ, గ్రేటర్ దాన్ 0 ఆల్ ఆర్ పాజిటివ్. వెన్ క్లియర్లీ ఫర్ ది value class of the quadratic form to be positive definite, all the eigenvalues should be greater than 0. That is k plus 1 greater than 0, k minus 2 greater than 0, అంటే k greater than -1 and k greater than 2. అంటే ఏదైనా కండిషన్ సాటిస్ఫై కావచ్చు, బట్ k greater than -1 is not satisfied, because in case k is equal to 0 అయింది అనుకోండి, when k is equal to 0 the eigenvalue is -2 ఎగ్జిస్ట్ అవుతుంది కదా. చూడండి, అబ్జర్వ్ చేయండి, k greater than -1 అయితే ఎనీ వన్ eigenvalues మస్ట్ బి నెగిటివ్ ఆర్ 0 అయ్యే అవకాశం ఉంటుంది మనకి. సో k greater than -1 is not satisfied. So k is equal to 2 చూడండి, k greater than 2, k is equal to 2 కూడా సాటిస్ఫై కాదు. k is equal to 2 అయితే ఏమవుతుంది, ఇక్కడ మనకి 0 అవుతుంది eigenvalue 1. So compulsory k greater than 2, k greater than 2 any value which is satisfied. If k greater than 2, all eigenvalues are must to be non-zero positive. So therefore only one condition, when k greater than 2, the given quadratic form is must be positive definite. Hence, the value class of the quadratic form is positive definite if k greater than 2 only. Okay, now that is the condition. Okay. Yeah. Thank you. This is the problems of quadratic form to finding nature, index, rank, signature by using eigenvalues of the coefficient matrix of given quadratic form. Okay. For more videos, please do subscribe my channel, like and share it. Thank you.